All right, so welcome to the final workshop of this week. Today's topic is about components and parameters in Fusion 360. So on Tuesday, we did the more introduction to Fusion 360 stuff, and now we're doing the other end of the spectrum where this isn't the most complicated thing in Fusion 360, but it's definitely more complicated and it brings in a lot of power to the software for doing bigger stuff, more complicated stuff. So the slideshow today is just going to be for our topics. So components. Let's talk about parent components. So I have Fusion open here, and I'll go ahead and switch to one of my other demo things. So I have a number of designs that I have brought in that we're going to talk about different aspects of them, and I'll be using them as a lot of the examples. So parent components. In this design, you can see all of the components have these cubes, and then the one at the top of the file has this cube with cubes inside of it. You'll notice that that's the same for all of the other designs I have open, except this one where you have components with or you have this, which has the same symbol, and that one has components inside of it. So components are like a generic bin for files or for parts of your design. And you can put a lot of different things into components, but the parent component is going to be what everything inside a file sits inside. And it'll always have the name of the file. So let's talk about components in general. So components are made by clicking new component here, or if you have a body, you can do this and create a component from bodies. Most of the time, I'd recommend doing it from the new component. So when you're getting ready to make a new thing, go to your parent component or go to whatever component you want to have it inside, activate that component, and then do new component. And components are really powerful because they let you organize your file, they let you do assemblies and more complicated effectively construction of your designs, and they let you do stuff like color cycling. So I'm going to hit S to bring up the design shortcuts, and then I'm going to type in color, and we have component color cycling toggle. Now you can see these have colors. Well, these already had colors before, so let's go to a design like the cube, and now that it has component color cycling on, you can see all of the different parts of the design have a color, and if I make one of these corners hidden, you can see each part is unique. So color cycling is a really powerful thing with components because especially when you get into designs with lots and lots of components, it's messy. There's all sorts of colors, all sorts of everything, and when all of these are one color, it can be even worse than it is like that. So we'll go ahead and turn that off temporarily. So when to stack components? Like I talked about at the beginning, our parent component is going to have components inside of it. Or if it's very simple, we can have few or no components inside of it. So this one just has two bodies that are in the main design, and then a component which I added as a secondary part of the design. But let's say we go to this design. So this is pretty complicated. This is a V6 engine approximation that I made, and it has a lot of different components. You'll notice that the core, which is the outer piece, is just a single component. You'll notice that I have some other things, like this was used to help in the physical assembly of it. It's just off to the side. But you'll notice each of the pistons is a piston assembly. So if I activate one of these, one of the first things you want to notice is the timeline down here, which has all of the build history of it, is reduced down to just the stuff related to what is inside of this. You also notice that these are piston assembly 1, piston assembly 2, piston assembly 3. This means that they're all copies. So if I make edits in one spot, it'll go to all the other spots. And that's super useful when you have, let's say, 6 of something. You'll also notice that inside this component, I have the joints. These are what link my parts together. most of the time, my answer of when to stack components is, are there joints between two components that you need maybe 6 copies of, or even just 3 copies of? If you need to make the same component group and use it a bunch of times, having them inside another component is a great way to do that. Because if you didn't, you would end up needing to do, for this model, these 5 joints for each of the pistons. So that's 5 joints and then copy it, or 30 joints. So stack stuff inside components when it significantly reduces the amount of time you'd have to take to design a file. The next thing we can talk about is saving copy as. So let's say you have a really complicated design, or just a design where you want to take something that you've already made and modify it, but you don't want it to be in that file. In this case, we're going to look at the corner. I can do save copy as. Slide workshop, components and parameters, cube 2x2 corner. I click save. Now, if I open this up, cube 2x2 corner. So I now have this design with all of its stuff here. And if I remember correctly, it also brings in all the parameters. So everything, and we'll talk about parameters more later, but if I now want to modify this, I can modify it here without affecting anything that I did before. And another thing you can do there is you can also modify it outside of the design. And then let's say you have a new modified version, and we can go back to the cube 2x2. Let's say we've made a bunch of modifications. We can now bring it back in as a linked file, and we can have this linked corner piece to our other design. So when you're designing stuff in Fusion 360 and using components and making these bigger parts, you can do everything as a separate file, or you can design in place, or you can do both. You can design in place and export, you can do mixing. You have a lot of different options there. And I'll go ahead and close that. Okay, so timeline organization. You'll notice that the timeline down here, everything is in groups. If I turn on color component cycling, you'll notice that all of these groups, it's the creation feature, which happens in the parent component, followed by all the stuff from one design. So this makes it way easier for you to modify your designs in the future, that when you want to look at something, you can see, oh, okay, so this grouping has all of my initial editing features. This grouping has when I did another thing. And you can even name these. Yeah, so these are named. So this is the internal front face, and that's what this part is. This is where I added the screws to this part and other parts. This is when I added fillets onto everything. This is when I added clearances onto everything. So you can really, really organize your timeline, and it can make your life a lot easier later on if you want to go back and edit stuff. You can also do some of this in post. So you can do stuff and then reorganize it back into place and then group it. And another nice thing about organizing your timeline is that how your timeline is organized affects how your parts show up over here. So let's say on this design, you can see all the corners are one after another. That's because if I go to corner, the very next feature is all the copy and movement ones. So the order that stuff is copied into your, or the order that you copy your corners in, will affect where they're placed. So let's say I make another copy of this part. So I have this new copy, and you'll notice that it's down here at the bottom. Well, I don't want it there. So let's see. Blue, these are fillets. And a lot of these are named, I think. Yeah. So here's where all the parts were copied in. And we can see this is in edge 7, in edge 8, in edge 10. Okay, so now I go in my timeline and I drag this to right there. And sometimes you do have to dissolve the group in order to move it in. That's pretty easy. You can just do delete group, and expand its contents. And then you should be able to move it. So now you can see that one we just made a copy of is now number 11, and they're all organized. So you can go back in post and organize your timeline, and it makes your life a lot easier when you want to do modifications. So that's timeline organizing. And then the last thing about components, don't reference other components directly. So this is something that I talked about in the earlier intro thing as well. But let's say I'm modifying something. Most of the time you don't want to do this. You don't want random projected geometry that you're building stuff off from, because there are two options for that. Something changes and your life is ruined, or you don't know what you're really getting with this. Obviously, if you're very, very careful about it, you can do that. But we're going to talk about something later that makes this a lot easier to do, and it's going to save you a lot of time and a lot of frustration. All right, on to joints and assemblies. So I'm going to go ahead and close some of the modified files. And let's reopen that. Okay. So regular versus as-built joints. So let's talk about joints first. Joints are what Fusion uses to constrain components. In a software like SolidWorks, you have mates, and they work slightly differently. So, for example, SolidWorks mates, you tell, I want these two surfaces to be in plane with one another, or I want these two lines to be in plane with each other. In mates, it's similar but different, and there's a concept of joint origins. So if I click on joint, and then I start clicking on stuff, you'll see all these little reference points come up. And let's say I want to grab something, like I want to grab this corner, but I don't want it to switch to that edge. I want it to be that face selection. I can hold down Control, and now while holding down Control, it only lets me select options from this face. So I can now grab that one in the corner. And then I can select another one. And you can see that it did it that way. Maybe I want it to be this way, who knows. But you can arrange the parts, you can tell it to flip what you meant. So maybe you actually wanted it to be them stacked on one another. And you can control motion. And there are a bunch of different motion types. So you have rigid joint, which is just, I want these two connected. Revolute, I want them to rotate. You can change the axis. Slider, I want them to move. You can also change the axis of that. Cylindrical, these are all pretty intuitive. A pin and slot, planar, and ball joint. So all of these different options means that you can make almost any movement that you want. And then once you're done that, you just hit OK. I'm going to go ahead and cancel because I don't want to do that. As built joints, as the name implies, it's taking whatever you've made, and instead of using joint origins to connect them, it's just saying the thing you made to the other thing as they are, but now with this movement. If you're making really complicated stuff, that can be really useful because it may be difficult to figure out what that as-built relationship should be. I personally try to avoid it, but either one is valid. On to joint origins. So sometimes one of the automatic joint origins that Fusion creates for you isn't what you want. You want something else. You can add joint origins to the part pretty easily using this. And then there's also rigid groups. So if you want stuff to just stay together and you don't want it to be any more complicated than that, you can tell Fusion that you just want parts to be in a rigid group with one another. Similarly to rigid group is grounding. You can right click on a part and say ground, and grounding will say, I want that part not to move in relation to the parent component. So that's useful for, in the case of our V6 engine, that the base here is grounded, and you can see by the little, or the core is grounded. And that just means I don't want the core to move really under any circumstance. All right, component movement. So joint setup, we already kind of talked about that. You can go in, select your motion. Motion linking and the contact sets. This is a really cool thing. And I think this design, which is a Geneva drive, is a really cool demonstration of it. So for contact sets, if you hit S to bring up shortcuts and then do contact sets, you can have all contact, specific contact, whatever you want to do. In this case, I think it's set to all contact. And you can see that when I rotate this joint by double clicking on it, that they actually move. And sometimes this is finicky, and if you have very sharp edges or very geometry that would be close in real life, it may have problems when simulated because it won't have the wiggle that something in real life would. So this is really cool, as well as moving the part like this. You can also do simple animation super easily to demonstrate movement. So you can just right click on a joint and then do animate model. And that will just automatically move that joint for you. And we can show the same thing over here, that I can do animate model. Something to keep in mind when you're creating joints is that the first component you select is going to be the component that moves, and the second component you select will be the one that doesn't move. So if nothing is grounded, that's going to be fine, but sometimes your rotation will be backwards if you do that selection backwards. But yeah, so you can see all of these components are moving together, and there's nothing telling these components that they are supposed to move other than the fact that, or like this joint is moving. And all these other things have constraints. So sliding constraints, rotation constraints, and that's what's causing them all to move. An alternative to doing everything like this is having motion links. So this is a ring box, and it uses motion links in order to get much of a similar effect. So in this case, when we do animate model, you can see that it opens and closes, and that's because everything is looking at this joint, and then this joint is moving back and forth. And this is another design where components are stacked. So you'll notice we have color component cycling on, and there's 3 blue and 3 red components, and there's also 3 here. So because the joint between the top face and the bottom face is present in all 3 instances, and they're literally the same part, when I was designing this, instead of making all 6 of these components, I made 2, put them in a group, made a joint between them, and then copied that in order to make the other ones. And this design is also using limits. So limits are a great thing if you don't want to deal with contact sets, because contact sets are effectively a mini form of simulation. You can use limits where you are just right-clicking and you're doing edit joint limits, and you just tell this, you know, you're only allowed to go from 0 to 90, or from whatever dimension to whatever dimension. And that way you don't get designs that are ridiculous, self-intersecting type things. All right. On to parameters. So this is the big thing in Fusion 360. The parameters are super, super powerful, and they let you do a lot of cool stuff. The first design that I'm going to talk about doesn't use that many parameters. And I'll go ahead and turn the color cycling off. So this design is what I was making for a mini drone body that I had the electronics and the propellers and everything. and I was just making a new body for it. So I didn't need to parameterize all of the parts of this because they're not changing. Like I have certain motors, I have a certain case. I can't really adjust those. So there's no point to have parameters for that. But what I can change is I can change the wall thickness. And for this one, I was doing a super thin wall design. And I just put the wall thickness here, and then any sketch that I wanted to use it in, I used shell a few times in this design. I can just reference the wall thickness by referencing this parameter that I've made called wall. And that makes it a lot easier for me to adjust the wall thickness if there are problems with it. So that's a super basic use for parameters, and it's a great way to use it. I think doing certain wall thicknesses and certain stuff like tolerances or clearances is a great option for parameters, just to have a few in the design, but it's not completely driven by parameters. Then this design uses a lot of parameters. So I'm going to go ahead and drive this to 15. Sure. So this design uses a lot of parameters. Basically, everything is driven by parameters. So I'm gonna show another thing real quickly. So change parameters is here. You can set it up into your design shortcuts. What I actually did is, because I use it super often, I went into here, changed keyboard shortcuts, and just set it to the P key. I think by default, project is on the P key. I don't use that. So for me, parameters is there. And you can see for this design, basically everything from the dimensions of the screw to a minimum strong wall thickness to the width I want to go with, magnets, offsets and tolerances, all of that are parameters. And when you're referencing parameters, let's say I go back to this early sketch, all you have to do is type in the thing. And you'll notice when I was typing, it does a fuzzy search, which is really nice. I've worked with some other software like SolidWorks, which does not fuzzy search your parameters. So you have to like know exactly what you're looking for. With this, let's say I wanted to search for width. I know I want the width, like, oh, I have screw width, screw head width, magnet width. I have all these different options. For this one, I wanted it to be edge, so it's edge. And let's see, changing value versus changing intent. So an important thing to keep in mind when you're doing parameterization is that parameters are great for changing design features. So if you have a new magnet, you can really quickly update that. If you're using new screws, if you want to change, you know, if you want to change dimensions, or like for the mirror cube, this is a great example. So the concept of a mirror cube, and I'll go back to when it was not scrambled. The concept of a mirror cube is that it's offset. So what I went and did is I made these offset dimensions. And I can make 100 different mirror cubes which have slightly different side offsets super easily. But something that you always need to keep in mind is that you can't change the design intent. For example, this Geneva drive, I have a drive number here. I can change this to 6. So this is now a Geneva drive, which has 6 of these increments. But it's still a Geneva drive. It still works the same way. It still has the same underlying geometry. So parameters let you change stuff like that. But if you need to like redesign or recreate a part, parameters aren't going to help. And that's one of the reasons that I really like them for tolerances and clearances, because that's something that there's a decent chance you're actually going to need to modify if you have problems. So by having them as parameters, you can save a lot of time and just quickly update them there. All right, so setup. Something that I have gotten in the habit of doing is, especially when I'm doing a more complicated design, I will have a planning component. So for example, in Mirror Cube, The planning component just has this sketch, and it has the visualization of the core. It has how the screws are lining up, how the outside edge lines up, that type of thing. And this is super useful because it tells you what you need, because you're going to need to make all of these parameters as you're filling it in. And it gets you in the right headset for how you're planning out the rest of your design. So I strongly recommend having some type of planning sketch when you're working with parameters, and also just when you're working on designs in general, that if you know what you want to do before you go into part design, you're going to have a much better time when you get there. So that's a thing. Somewhat related to components and parameters as well. This design uses a cool feature of Fusion 360 called CopyPaste New. So before, when we talked about making the corners for the 2x2, we had copied and pasted all of these. Well, for this design, they're all unique. So instead, it involved doing a copy and then a paste new. And that makes a new component, which is not connected to the old component. However, let's say you used your parameters in your sketches. It's still linked to those parameters. They're still present. So what that meant is that instead of redesigning every piece of the cube for the corners, I made one corner, and then I made 7 other corners, and I changed X to Y, and Y to Z, and Z to Y, and Y to negative Y. And I just referenced these parameters that I had made early on. So setup for parameters, I think that's pretty much covered. Units. Units is another super important thing. So you'll notice that this one has just nothing here, and this one has degrees. Units right now are set in stone once you make a parameter. So when you do add and you type something in here and choose a unit, you can't change that unit in the future. What you can do is type equivalent types of units. So let's say test. So parameter name is test, units is millimeters. I can put this in as 1 inch. I can include the units in another type of unit, and it will just convert it into that size. But I can't do like 1 meter cubed. No, because meter cubes and millimeters don't have a conversion. So just remember that if you want an angle, you're going to have to tell it that you want an angle. Then let's see, units. Referencing other components. Yes, so our final thing, referencing other components. You can use parameters to do that. So in the case of this one, if I go to the maximum depth, which it doesn't like to show, this is a relationship which you could do with projecting. You could draw this out with everything projected in here. Instead, what you can do is you can have a parametric relationship between the two designs that I'm looking for the sketching here. So this is all based on parameters. Something that I actually learned when I was making this Geneva drive is that you can't assume certain connections. Originally, I defined it as 2 circles, where I think it was like this radius and this radius. And that's a problem because sometimes for 2 given radiuses, that breaks. That just stops working. So making sure that the parameters you're using accurately define your object is another important thing, because otherwise your design will have like a boundary case where everything just breaks down. You'll also notice in this design that there's all these faces, and that's because this part was copied a bunch of times and or mirrored and patterned so that I only make one section of it, and it means that I can do funky things like that. And you'll notice some stuff breaks down, so you'll have to go in and probably let's see. This is the fun part of parameters. a lot of the time you're going to have to adjust the numbers because they don't make sense or they don't line up with the new values you've chosen. Yeah. So not all dimensions are valid dimensions to put in. But not making such a big jump can also help to make it convert more easily. All right, so that was our using parameters. And a similar thing we can talk about with the cubes, that like the internal everything of these is all, it's all referencing parameters. None of these are looking at other parts. They're all looking at the parameters, and that's making them so that they line up. Okay. Deriving. So deriving is another really cool component of Fusion 360. So let's say I want to put something on the outside of this box, and I still want it to be linked to this design so it'll update. What I can do is I can do derive, and you'll see that there is both derive and insert derive. Pretty intuitive. This one takes something out of your current file. This one puts something into your current file. So I'm going to go ahead and hit derive. I'll do save and continue. Okay. And I'm going to just take this whole face set. And you have a couple different options here. You can either create a new design or you can add it to an existing design. You can also copy parameters. From component means it'll bring over all the ones that are in your currently used or currently selected components. Or favorites, you can favorite parameters. If I jump out of that for a second, this star here lets you favorite parameters. So if you want to use a bunch of these parameters in your other files, you can go ahead and do that. And I actually made a space organizer that used that functionality, that all of them reference the same base set of parameters. So you updated the base file and it updated all the other parts of the organizer. Okay, so we're going to derive this again. And we're going to do from components and new design. Okay. So you can see in this design, we used a reference plane, so that's been made visible. And I can go ahead and do whatever I want in this design. So I'll turn that off. And the joint is still there, everything's still there, and you can see this little arrow, meaning that it's linked to the other component. If I save the other component, this one will say that it's out of date. If we go into parameters, you can see we have this new section down below the model parameters, which has all of the user parameters, all the other stuff. You notice that all of these have ref added after them, and they're grayed out. So if I just try and do extrude or something, and normally I could put in edge, I can't. You either have to type, or normally I'd be able to do this and it would give me search results. You have to type in exactly what you're looking for those parameters. So that means you have one of two options. You can either just make sure to type in the full thing all the time, or let's say I know that for the thing I'm doing, I'm going to need to reference the screw head depth a bunch of times. So I can just remake the screw head depth parameter like that. So now I have this. It is referencing our reference dimension. Now, screw head depth. There it is. So that's a super easy way to get these reference parameters into a searchable format. Or you can favorite them. Depending on what you're doing, either one may be beneficial. So now I believe this lets me do, yeah. So if you favorite them, they also become searchable. So that is deriving parameters and deriving components. It's super powerful and lets you make really complicated designs that are all based around one system. And that is also the end of what I had planned for the workshop. So if anyone has questions, go ahead, and now is the opportunity. All right, so if you have any questions or feedback after watching this recorded workshop, go ahead and put them down in the comments. And while this is the end of the workshop series that we did with Startup Shell, we're definitely going to have a lot more videos over the summer and in the future.